So let's think about what are all the things we looked at. We saw the rules for N, we saw the rules for L, and we also saw the rules for M sub L. And we said that N gives us the energy of an electron in a specific area, and L tells us about the shape of that orbital, and M sub L tells us the orientation. So if you look at it combinedly, so we're at this point considering three different main energy levels, N1, N2, and N3. If N is 3, L is 0, 1, and 2 values. N has 0, 1, and 2, and that's what these are. L0 is known as s orbital, L1 p orbital, 2 3 d orbital. Again, L0 s orbital, L1 p orbital. Now here also there is an s orbital, here also there is an s orbital. What's the difference between two? This s orbital belongs to N3, whereas this s orbital belongs to N2. So this is known as the 3s orbital, and this is known as the 2s orbital, and same way 1s orbital. Right? The other pattern that you will notice is that all s orbitals you have only one orbital, because there is only ML0. Remember, every ML is one orbital. Okay, every ML is one orbital. Every single ML is one orbital, and it can take a maximum of 2 electrons. So 2 electrons here, 2 electrons here, and 2 electrons here. Okay, now same way p orbitals. This is 2p and this is 3p. What is common to the two of them? All of them occur as a set of 3 orbitals. These are degenerate orbitals. They have the same energy. Why do they have same energy? They have same energy because they have same n. So n for this one, for all the 3 of these orbitals, n is 2. If n doesn't change, energy doesn't change. So all 3 of them have same value of n, so they have same energy. They are all degenerate orbitals. So these sets all of these sets are known as are all degenerate orbitals. So these 3 are degenerate, they have same energy. These 5 are degenerate, these 3 are degenerate, like that. So all of them have, so these 3 have same energy, 5 of these have same energy, 3 of these have same energy, right? They are degenerate orbitals. Now remember, each M sub L is one orbital and it can take 2 electrons each. So 2 electrons here, 2 electrons here, and 2 electrons here. So total of 6 electrons in 2p orbitals. Again, a total of 6 electrons in 3p orbitals. So any p orbital, whether it's 2p, 3p, 4p, 5p, whatever it is, it will only take 6 electrons. Same way, d orbital, they will take a maximum of 10 electrons. It can't go beyond that. It can be less, but it can't go beyond that. Now all these 3 orbitals, if you remember the shape from last video, all the 3 of them have a shape that kind of looks like this. This is a dumbbell, right? And there are 3 of them. One is oriented towards the x-axis, another one is oriented towards the y-axis, and the third one is oriented towards the z-axis. So this is px, py, and pz, mutually perpendicular axis, pz. Just so I can make sure, let me just draw the perpendicular axis first properly. So this is x, y, and z axis. So px, this is better, py, and pz, right? This is what it looks like, and you should also check it in the previous video. Just like that, there are 5 d orbitals. So if L is equal to 2, m sub L is -2, -1, 0, +1, and +2. This could be 3p, 4p, 5p, right? Excuse me, 3d, 4d, 5d, not p, this is d. So this could be 3d, 4d, 5d, whichever it is. There will be a set of 5 orbitals which can take a maximum of 10 electrons. And how do these look like? Each one of these, okay, there is a dxy orbital, dxy orbital, okay, which will be located in between the x and y axis. So if this is the x axis, let me just draw it properly here. X and y. So okay, so this will be located in between the axis, and I did not draw the third axis here because I wanted to show you the orientation. So xy comes in between the x and y axis. So you can say that it comes in the xy plane, which I'm showing on the plane of the paper right now. Okay, and then like this, there are 4 other orbitals, dyz, dzx, so all of them, dxy, dyz, and dzx. They are all oriented in these respective planes. And then there are 2 other orbitals which are dx squared minus y squared. This comes in the x and y axis, along the x and y axis. And then there is dz squared, which comes in the z-axis. It comes along the z-axis, but it looks a little bit different than the other 3. It has kind of a lobe. It looks different from the other 4, excuse me. So this is along the z-axis, and then it kind of has a ring that surrounds this area. So this is the z-axis. But this is all for you to visualize. What we would like you to remember, okay, is that there are 5 d orbitals. These are the names, and just have an idea that they have 4 lobes. It's a double dumbbell shape except for this one. Okay, so just to make sure, remember these points. How many electrons does it take? What's the maximum number of electrons? You really don't have to draw orbitals, but you should be able to recognize orbitals when pictures are given to you.